All right, so before we move on to the next geometry lesson, we do need to discuss simplifying radicals and taking the exact square roots. So when you hear or you see a worksheet or something or question that says, what is the exact answer? This is what it means. So first, let's discuss perfect squares. So you should remember from years ago what your perfect squares are. It's a number that when you multiply it by itself gives you a resulting perfect square. So I'm going to write these at the top, and we are going to, you should have these memorized. So here we go. 1, 4, 9, 5, 36, 49, 64, 81, 100, 121, 144, 169, 196, that 14, 15, 15, 225, 16, 216, what's 17, 289, 3, oh boy, 3, I think it's 324. I think 18 squared is 324. Let's see if I'm right. Let's see if I know math. 18 squared. Correct. 19 squared. I'm going to go up to 20. Why not? I don't have anything else to do. Just might as well keep squaring numbers. 361 and 20 squared is 400. Hopefully we will not get up to these very large numbers. So for the most part, our questions will stay relatively small. But here we go. You should have done this last year. And some teachers teach it a different way. So I'm going to tell you this. I'm going to do it right now, and I'm going to do it the way that we are never going to do it again, which is the following. The square root of 28. Let's pretend this was the problem. Some teachers are going to teach you to do this. Oh, let's see. 28. That could be 14 times 2. And 14 times 2, well, that's just 7 times root 2. Oh, that's a pair. Pull it out. Root 7. We're not going to do it this way. We are going to recognize what a perfect square is and factor it out. So, goodbye. From this list of numbers, you are looking for which number is a factor of 28. And there's only one of them. It's 4. So root 28 can be written as root 4 times root 7. And I believe that most of your teachers were doing it this way last year. If you were doing like the buddy system, we're not doing the buddy system. It takes too long when the numbers get very large and you wind up confused. There's a lot of buddies sometimes. So we're going to just do it this way. The square root of 4 is 2. The square root of 7 is not a perfect square, so it's just root 7. Done. That is the exact answer. Do not put this in a calculator. I will know if you've watched this lesson, because if you didn't, you're going to give me decimals. Let's see what happens. Root 54. Great. 54. Which one of these numbers up here is a factor of 54? Well, it can't be more than 49, so it's going to be root 9 times root 6, because 9 times 6 is 54. The square root of 9 is 3. The square root of 6, I don't know. Leave it alone. 3 root 6. 150. Don't say 10. 10 is not a perfect square. Don't say 15. Also not a perfect square. So if you look at your list of perfect squares, you can start to test them out in your calculator. It's not divisible by 4, but it is a multiple of 25. 150 is just 6 25s. So the square root of 25 is 5 root 6. Done. 720 getting large here. Let's see, 720. So let's just see. At some point, you just have to start testing out numbers. Again, I know it ends in a 0, but it's not going to be 10 because 10 is not a perfect square. Neither is 72. Let's just go with, I feel like 36 is going to be a good number here. Oh, we can go higher. So I will show you the highest number first, because that's going to be easiest. You always want to take out the highest number. So in this case, the highest number is 144. Although I don't know if you would have just guessed that right off the bat. So it's 144 times 5. That's how you get 720. This would be 12 root 5. Now, we know that this is the answer, but most of us, just like myself, are going to probably see a relationship between 720 and 36. And that's fine. 36 times 20 is 720. The square root of 36 is 6. But you can never leave a perfect square inside of a radical. So if you look at 20, there is a perfect square that can be factored out of 20. It's 4. 4 times 5 is 20. So if you were to write 6 root 20, that is incorrect. The square root of 20 can be broken down more into root 4 times root 5. And now root 4 is dose and root 5. Oh no, the 6. He's still hanging out here. Now remember, this was 36 times 20, so you're just going to keep multiplying. And you're only going to multiply whole numbers times whole numbers. 12, yes. And radicals times radicals. Technically, there's a radical 1 here, so that would be radical 5. And look at that. Same answer. A little bit more work, but if you don't find the highest perfect square, you have to just make sure that all of the perfect squares are factored out. I'm going to skip around real quick to number, I don't know, I'll do 11. So here we go. Oh no, there's already a number outside of the radical. That's fine. Press pause, hold on to it for a second, and just look at the radical. The radical has a factor of 4 times root 3. Root 4 is 2. Root 3, I don't know. And the 3 was originally just touching the root 12 or multiplied by root 12. So here comes 3 multiplied by the result of the square root of 12, which is going to be 6 root 3. I'm going to stop doing these out loud. If you want to just scroll through to the end of the video, you will have all of the answers there. You can check them and then work on the independent assignment. One more thing. Hopefully you didn't fast forward yet. Please, please, please. If there is just a perfect square under a radical, just do the square root. It's 3. No need for trees. No need for breaking down 9. It's already a perfect square. Here we go. Here's the rest of the answers.